You open your video editor, build your timeline, and hit export, only to hit a paywall. Basic transitions and resolutions that were free yesterday suddenly require a premium monthly subscription. The financial cost is only part of the problem. Behind the scenes, closed platforms routinely scrape your raw, unreleased footage to train their proprietary AI models, burying the permissions deep within their terms of service. OpenCut provides a direct solution to both issues. It is an MIT-licensed, open-source video editor that runs entirely inside your local web browser. To run it locally, you need 4 specific things: 2 GB of RAM, Docker desktop, the Bun JavaScript runtime, and a terminal window. By abandoning cloud-tethered ecosystems and self-hosting your software, you keep your data isolated on your hardware, removing the risk of third-party harvesting or arbitrary monetization traps. Step 1 is securing the local environment. Open your terminal, clone the primary OpenCut repository, and create a file named .env.local to hold your configurations. This interface shows the exact OpenSSL command you need to run to generate a 32-character cryptographic string. Paste that exact alphanumeric string into your .env.local file to secure your local user sessions. Do not skip this key generation step. If the application cannot locate this precise 32-character string, authentication will fail and the editor will crash immediately upon launch. With the security key in place, run a single Docker Compose command in your terminal to launch the database and caching microservices. This flowchart illustrates what that command builds. The central server node connects to a Postgres database storing your project metadata. It also connects to a Redis cache handling local rate limiting. When both blocks pull green, you have established a healthy live connection. You now have a fully isolated backend infrastructure running on your machine, completely severing any reliance on external third-party servers. Step 2 is compiling the front end. Run bun install to fetch the workspace dependencies, and then execute bun dev web to boot the local server. Once the terminal confirms the server is active, open your web browser and navigate to your local host address to load the interface. OpenCut organizes its timeline using what it calls scenes. A scene is a self-contained, independent timeline, allowing you to manage distinct video chapters without them interfering with one another. Import a local media file from your hard drive into the media bin and drag it directly onto the active timeline. This diagram demonstrates the timeline's 4 distinct track types: video layers for footage, audio layers for sound, text layers for captions, and sticker layers for graphics. Their vertical stacking order determines the z-index rendering priority. The top layer will obscure the layers beneath it. Because this editor operates entirely within a web browser sandbox, it faces physical limitations, specifically JavaScript memory caps and the processing overhead required for garbage collection. Attempting to stack dense, uncompressed 4K multicam clips on a single timeline will quickly overwhelm the browser's memory allocation and crash the application. Managing how the browser allocates local memory allows you to build complex projects without reaching these performance ceilings. Step 3 is the export. Once your sequence is complete, trigger the rendering process. Note the current technical constraints here. OpenCut relies on 8-bit color quantization. This means it cannot natively support the uncompressed 10-bit color spaces required for cinematic post-production. Instead, the application utilizes WebAssembly and WebGPU to process millions of video frames directly on your local hardware, entirely offline. This logic chart tracks the system export process. On the left, the local rendering progress bar fills up. On the right, network traffic remains flat at 0 megabytes per second. With 0 network traffic, the entire rendering pipeline remains locked to the client side. Producing a finished file under these conditions guarantees complete sovereignty over your data, ensuring absolute immunity from corporate scraping and data leakage. Locate the generated file you've exported. It is resting safely on your local hard drive. You have successfully completed an end-to-end video export with 0 cloud uploads. Next time, we will explore OpenCut's headless mode. We will look at how this mode interfaces directly with the Model Context Protocol. This protocol empowers AI coding agents to fully automate complex timeline editing workflows purely through simple text commands. Mastering this local, isolated foundation is the required first step before handing the reins over to those automated agents.